So when we have a problem that has all this information and you want to change it into different units, it's inevitable that some of them are going to be much easier and faster than others to do the conversions. So we have percent mass, and that's first. Remember, that's the mass of the solute. And notice right here, we're doing NaCl. You're adding that to the water. So it's 134.1 grams of solute, which is salt. We're going to be multiplying it by 100%. And on the bottom, this is grams of solution. It could be written like that. It could also, remember, be the same thing as grams of solute plus grams of solvent if you don't have the solution amount. In this case, we have the solution. So this one is actually a really easy one to do. So 202 grams of solution. So that should give us 134.1 divided by 202 times 100. So that is 66.4%. And it's 0.4 because there's 1, 2, 3 sig figs there. Now we'll do mole fraction. Now this one, I don't have moles in any of these, and so I'm going to have to do a little bit of extra work to get to mole fraction. It might be easier for me to jump to molarity, so you can also think of that, because notice I've got a lot of solution stuff in here. So if you ever have to do 4 units, think that there's some different ways that you can actually solve these. You don't always have to solve them in order. But in this case, I need to figure out moles of solute for the top. And I need to figure out moles of solvent plus moles of solute. And the reason I have to write it like that is because there's nowhere in the problem that it gives me the molar mass of the solution, because the solution has like a certain percentage of NaCl in it, a certain percentage of water. It's related to what the density is, but it's a certain amount. And so we don't have that information. So I do have the information for each molar mass. And of course, we know the molar mass of water. If you don't have it memorized by now, just go ahead and memorize it up. This is 18.02. So what I'm going to need to do is do my moles of solute. So over here to the side, I'm going to make a little space to write some work out. So I'm going to scooch these ones down just a little bit. And what I need to do is calculate each of these. So I've got 134.1 grams of NaCl. And if I need to get in that moles, then I'm going to use that number just above, 58.44 grams in 1 mole of NaCl. That will give me my moles of NaCl. Now for the water, I don't actually have how much water I have, but I have how much solution I have. So if I do 202 minus 134.1, that gives me that I have 67.9 grams of water. So I can take my grams of water and I can turn that into moles of water. So I'm going to do both those calculations at the same time. So I'm going to make that slightly smaller so I can see my numbers. 134.1 divided by 58.44. So that would normally have 4 sig figs. I'm going to give it an extra 1 or 2 just because I'm not done with my math here. So 2.294, we'll just write 66. So that's how many moles of NaCl that I have. So I'm going to kind of mark that. So again, that was a 2 in the front there. My square kind of looks a little funny. Now over here, 67.9 divided by 18.02 gives me 3.78 grams of water. And of course, some of these numbers are going to be crazy numbers here because we're just trying to kind of teach you how to do some of this. So, and that's not grams, that's moles. My bad there. And so I'm going to do 3.78 moles of water, and I've got my moles of NaCl. So I can put all my numbers in now, and notice I did not keep enough sig figs there, so I'm going to go back and add some sig figs. 3.7 6804. So to work this problem, I'll do 2.29466 moles, and that's for the NaCl, over, and this is together, 2.29466 moles of NaCl plus 3.76804 moles, you zoom in, of water. And this is the NaCl mole fraction, so we can also figure out the other mole fraction too. So I'm going to put this in my calculator. So 2.29466 divided by parentheses 2.29466 plus 3.76804. So that gives me that my mole fraction for NaCl is 0.378. Now the difference, if it had asked me for the mole fraction of water, is that this number would have been on top, but the bottom part would have stayed the same. But the quicker way to get to the mole fraction is to subtract the first number from 1. It's kind of like having a percentage and subtracting from 100 if you only have 2 percentages. So if it had asked me for both, that gives me, oops, minus 1 minus answer 0.621. And at this point, this is a subtraction sig figs, and I can't randomly just say that the one has one sig fig, so I have to maintain all those significant figures. My total mole fraction there would be that number. So that's my mole fraction for water.